Welcome to the DIY Honda Garage channel. The DTC P0010 specifically relates to a malfunction in the variable timing control, VTC, oil control solenoid valve of Honda CRV models from 2011 to 2016. This component is crucial as it adjusts the timing of the engine's intake and exhaust valves based on engine speed and load conditions. The solenoid valve is typically located near the engine cylinder head and is activated by oil pressure to control the variable valve timing mechanism. This type of fault can lead to performance issues, including reduced engine power, increased emissions, and poor fuel efficiency. When you face this diagnostic trouble code, it's vital to follow a systematic troubleshooting procedure in order to resolve the underlying issue effectively. Regular diagnostics play a significant role in maintaining optimal vehicle performance and longevity, and DTC P0010 is frequently encountered during such checks. The VTC oil control solenoid valve is responsible for controlling the timing of the opening and closing of the engine's valves. This valve manages oil flow to the VTC mechanism, allowing for precise adjustments in valve timing. Located near the engine cylinder head, it is subject to wear and tear and can malfunction due to various environmental factors or electrical issues. The oil flow through this valve is critical for optimal engine performance, emission control, and fuel efficiency. If the DTC P0010 is triggered, it indicates a significant problem with this component that must be addressed immediately to avoid severe engine performance degradation and potential damage. This malfunction can arise from operational factors such as excessive dirt or oil contamination, which may hinder the valve's movement. Several factors may lead to the activation of DTC P0010. The most common cause is a faulty VTC oil control solenoid valve itself, which can fail due to age, excessive heat, or oil contamination. Another frequent culprit is wiring issues, such as frayed or damaged wires, leading to poor electrical connections. Poor connections at the solenoid valve or the powertrain control module, PCM, can also trigger this error, as they impede the electrical signals necessary for proper functionality. Additionally, software issues within the PCM might contribute to this code if it has not been updated to the latest standards. Therefore, a thorough investigation of these potential causes is crucial in resolving the DTC P0010 issue. The symptoms of DTC P0010 can manifest in various ways that affect the vehicle's performance. Drivers may notice significant performance issues such as reduced power during acceleration, which can deter from a smooth driving experience. Increased emissions are also a critical concern, as a malfunctioning VTC solenoid can lead to improper fuel burning, ultimately violating emission standards. Additionally, changes in engine noise and rough idling may occur when the solenoid fails to regulate the valve timing correctly. Engine warning lights may illuminate on the dashboard, indicating an underlying issue that needs addressing. Lastly, poor fuel efficiency may become evident if the variable valve timing systems are not functioning optimally, making it critical to troubleshoot DTC P0010 promptly. For the first troubleshooting step associated with DTC P0010, begin by turning the ignition switch to the on position. This allows the car's diagnostic system to be activated without the engine running. Next, use the Honda Diagnostic System, HDS, to clear the current diagnostic trouble codes. This action provides a clean slate for testing. Once cleared, start the engine and hold the RPM at about 3,000 without any load, either in park or neutral. This step is essential as it allows the engine to reach optimal operating temperature while monitoring systems. After doing this, allow the engine to idle and execute the variable timing control (VTC) test in the HDS's inspection menu. Finally, check again for any pending or confirmed DTCs to see if P0010 reappears. Recording this data is vital for accurate diagnosis. Step 2 requires turning the ignition switch to the lock position, ensuring that the system is completely powered down. This step increases safety during the testing process. Next, you will need to disconnect the 2P connector of the VTC oil control solenoid valve. This disconnection is necessary to test the resistance effectively without interference. Utilize a multimeter to measure the resistance between the two test points designated on the solenoid valve side, test point 1 and test point 2. According to specifications, the resistance should read between 6.75 to 8.25 ohms at room temperature. If the measurement falls within this range, it indicates that the solenoid is functioning properly, and you may proceed to the next troubleshooting steps. If the resistance is outside of this range, however, it signals that the VTC oil control solenoid valve is defective and should be replaced. The third step in the troubleshooting process focuses on ensuring the integrity of the PG1 line. Begin by checking for continuity between the designated test points, using the same disconnection state as before with the VTC solenoid valve. Test point 1 should be terminal number 2 of the VTC oil control solenoid valve, while test point 2 should connect to the body ground. This step verifies that there is an uninterrupted pathway for electrical signals between the solenoid and body ground. If continuity is confirmed, it means that the PG1 wire is intact and functioning correctly, enabling you to move on to the next troubleshooting step. However, if there is no continuity, it indicates an open circuit somewhere in the line. In that case, you will need to locate and repair the broken section of the PG1 wire to restore its function before proceeding. For the fourth step, you will begin by jumping the SCS line with your HDS, ensuring that the connection is securely made to facilitate testing. After this, disconnect the PCM, Powertrain Control Module Connector, C, which consists of 49 pins. With both the VTC Oil Control Solenoid 2P connector and the PCM connector unplugged, continuity needs to be checked between specified test points. Test point 1 corresponds to the number 33 wire of the PCM connection, which is blue, while test point 2 should connect to the body ground. This step ensures that the VTC P line, responsible for signal communication between the VTC solenoid and the PCM, is functioning correctly. If continuity is established here, it indicates that there isn't a short in the VTC P wire. If continuity is absent, it will require identifying and repairing the short in the wire connecting the solenoid to the PCM. The final troubleshooting step emphasizes checking for continuity in the VTC P line. Once again, make sure that the VTC oil control solenoid valve 2P connector and the PCM connector are both disconnected. Check continuity between test point 1 at the solenoid connector number 1 and test point 2 at the PCM connector number 33. This step verifies the functionality of the VTC P wire connecting the VTC solenoid to the PCM. If the test confirms continuity, this indicates the wiring is intact and functioning properly. In this case, updating the PCM software to the latest version is advised, or substituting it with a known good unit. However, if the continuity test does not pass, repairs need to be conducted on the VTC P wire between the solenoid and the PCM to ensure electrical signals can appropriately communicate. After completing all necessary repairs associated with DTC P0010, it's crucial to perform a final verification to confirm that the issue has been resolved. Start by turning the ignition switch to the lock position and reconnecting all previously disconnected connectors. Once everything is secure, turn the ignition switch to the on position to activate the vehicle's systems. Proceed to reset the PCM using the Honda Diagnostics system to refresh it for new data signals. Completing the PCM idle learn procedure is critical to recalibrate the PCM for optimal engine performance. Finally, execute the VTC test within the HDS's inspection menu to ensure no faults persist. Monitoring the OBD status for DTC P0010 is essential. A result indicating passed will verify that the issue has been successfully resolved. Preventive maintenance is essential in keeping the VTC system functioning at its best and avoiding the recurrence of DTC P0010. One of the most effective strategies is to schedule regular oil changes, using the recommended oil type to minimize sludge and debris that can clog the solenoid valve. It's also crucial to periodically check for any wear and tear in electrical connections and wiring associated with the VTC system to ensure optimal performance. Ensuring that you update the PCM software whenever updates become available can also help prevent issues related to compatibility or bug fixes that affect functionality. Adopting these preventive maintenance practices not only helps in avoiding potential future DTCs like P0010, but also promotes the overall longevity of your Honda CRV. In conclusion, DTC P0010 represents a significant issue with the VTC oil control solenoid valve, which can affect the overall performance and efficiency of your Honda CRV. Following a structured troubleshooting process is vital in pinpointing the root cause of the error to ensure proper repairs. Each step, from testing the solenoid resistance to checking continuity in wiring, plays a critical role in diagnosing the issue correctly. Once repairs are made, final verification ensures the diagnostic code is cleared and not returning. Additionally, adopting preventive maintenance practices keeps the system functioning efficiently and helps to avoid similar issues in the future. Regular checkups and maintenance optimize vehicle performance, enhancing both safety and longevity. Please like and subscribe to the channel. See you next time.